Hello everyone, so I'm Dr. Tushar Mehta. I'm an orthopedic surgeon and your faculty of orthopedics. Well, it's a small video and it is about a question which is there in the eMedico's app. It's the first question in the orthopedics image-based test. So what they've done in that question is they've given you a image which shows a deformity and they've asked you to identify the deformity and the nerve associated with that deformity. So I thought that I'll take it a little further. So I'm sure you all can visualize this picture. There are two hands which are presented in front of you, and as I've labeled, and I'm sure you're able to understand that this is hypothenar eminence while this is the thenar eminence, and you can see that in this particular hand there's a well marked normal thenar eminence with all its fullness, but when you see it on the other side you see it atrophied. Now this atrophy of the thenar eminence is very important here for all of us to understand. I'm sure by now you must have knowing this, that thenar eminence basically consists of 4 muscles, out of which more or less 3 muscles are supplied by median nerve. So why would a thenar eminence go into atrophy? Because of the median nerve paralysis. So first thing we have understood here is this, that if we see a hand which has thenar atrophy or atrophy of the thenar eminence, then that is precisely due to the involvement of the median nerve, that is precisely due to the median nerve palsy. Now how is this image relevant and important to that question number 1, which is asked an image-based test of orthopedics in eMedico's app? I'm sure you can see in this image again that how you have the hypothenar and the thenar eminence which are quite prominent, and here you can see the atrophy. Now I would like to just give you a brief on this, that with the evolution of the mankind, with phylogenetic evolution of the mankind, there is only one difference, one classical difference, and one important peculiar property that a human hand has as compared to the rest of the other animals is this, that we have these 4 fingers which are parallel to each other. Of course, this is something that you can see in other primates as well, but this thumb is actually at the plane of 90 degrees to the rest of the palm and the rest of the fingers. Where in other animals, if you see, then it is not there. They don't have a prominent thenar eminence, and because of that their thumb is not at the plane of 90 degrees. It is parallel to the rest of the 4 fingers. So this is according to the evolution, the phylogenetic evolution of the mankind that happened. So we have come to this conclusion that according to the concepts of it, there's a functional capacity of the thumb is modified in humans, and there is only and only one modification which is makes it standalone, and that is to oppose. So when I say opposition, that means when you can touch the tip of the thumb to the tip of the fingers of the same hand. So no animal except the human has a truly opposable thumb. Now when we talk about ape thumb deformity, which is also called as, please try to remember, simian hand. So ape thumb deformity or simian hand is basically when you cannot move the thumb away from the rest of the hand. Why? Because of the paralysis of the thenar muscles. Why? Because of the median nerve involvement. Are there any other causes? Yes. Now this is very important for all of us to understand, that simian hand or ape thumb deformity is not only due to median nerve paralysis, it can be due to a cause like polio. It can be due to an etiology like leprosy. So this is what I wanted to convey with this image, that all in all, that question shows you a deformity of ape thumb deformity, also called a simian hand. Bottom line is clear, that in humans the thumb is opposable. When I say opposable, that means it is at the plane of 90 degrees to the rest of the palm and the rest of the fingers. But when there is a median nerve palsy or leprosy or polio leading to atrophy of the thenar eminence, then that thumb is appearing as if it is parallel to the rest of the fingers, and it loses the power of opposition to the remaining fingers. So this is all about it. I'll be coming up with more video solutions of the various questions, and the in the DQB and the bounce back and the clinical vignette based from the eMedico's app in due course of time. So stay tuned to such explanations, and we will try to take those questions a little step further with the explanation of the entire topic, so that you are able to imbibe overall as a whole. Thank you so much. All the best. Bye-bye.